This video is on Unit 1, Chapter 3 on Systems of Equations, Lesson number 1, Solving Systems by Graphing and Substitution. To start off in your notes here, the definition of systems of equations says two or more linear equations. As we progress through the chapter, what you're going to find out that a system can be more than just linear equations. You can have two or more equations of any kind. And the solution to any system is the point or points of intersection. So let me add that. The solution is the point or points of intersection. And again, they don't have to be just linear equations. Now, we're going to focus strictly on linear equations here, but as we progress throughout Algebra 2, it's going to include things other than linear. So the types of solutions that you're going to see here in this lesson can be one solution where the two lines hit each other at one point. In that situation, your answer will be an ordered pair, so x, y, an ordered pair form. You might have no solution situation where the lines don't hit each other at all. Those are parallel lines. And then infinite solutions is going to be where your two lines actually are the same line. So you graph the two lines and they're the same line. Because again, you're looking for the points where they hit, the points of intersection. So the reason why this first one has one solution is because that's the only place where they hit each other. Parallel lines are no solution because they don't have any points in common. And then with infinite solutions, because of the same line, all of their points are the same. So quickly going through some examples, solving by graphing, we're just going to graph by hand or by using the graphing calculator and look for where the two lines hit each other. So looking at example number 1, both equations are in the y equals mx plus b form. And again, that is slope intercept form. M is your slope. B is your y-intercept. So for the first equation, y equals negative 5/3 x minus 6. My slope is negative 5/3, and my y-intercept is negative 6. So to graph that by hand, you want to start on the y-axis at negative 6 with a dot. And then we're going to use our rise and our run from our slope to graph another point. So we want to rise negative 5 and run 3. Now I can't go down 5 because I don't have enough lines on here. So instead of going down 5 and right 3, I'm going to go up 5 and left 3. 1, 2, 3, 4, 5, 1, 2, 3. So there is your line. Oops. Imagine that actually hit those dots. So there's the line for the first equation. For the second equation, y equals 1/6 x plus 5. The slope for the second line is a positive 1/6. The y-intercept is the 5. So again, to start graphing this, we're going to start at 5 on the y with a dot. And then we're going to rise 1 and run 6. So up 1, right 6. Or the opposite of that is down 1, left 6. And there's that point. So here is the point of intersection, which looks like it's at negative 4, 4. No, negative 6. Sorry, negative 6, 4. So the point of intersection is the solution to the system. Let's look at number 5. Let's jump down to number 5. Number 5, we've got 2y is equal to 8x plus 18 and 24 plus 4y is equal to x. So the first thing that I'm going to do is I'm going to take that first equation and I'm going to divide everything by the 2 that's on the y. And I get 4x plus 9. So I'm going to graph that one. That one has a slope of 4, which would be 4 over 1, and a y-intercept of 9. So it hits the y-axis at 9, and I need to rise 4 and run 1, but I can't go up 4 and right 1, so I'm going to go down to the opposite and down and left. So there's that line. For the second equation, 24 plus 4y equals x, I'm going to subtract the 24 and divide everything by the 4. And we're going to get y equals, that's a 1/4 x minus 24 divided by 4 is 6. So for the second equation, we've got a slope of 1/4 and a y-intercept of -6. So I'm going to start on the y-axis at -6, and I'm going to rise 1 and run 4. So up 1, right 4, or down 1, left 4. And I'm thinking that this is actually my point of intersection. My other line just didn't extend far enough. So that's the point of intersection there, which would be -4, -7. So -4, -7 is the solution to number 5. So I want to show you very quickly what this might look like if you choose to graph in the graphing calculator, use the graphing calculator. So I'm going to jump to the y equal part. So all I've done is I've grabbed my graphing calculator, I've gone to y equal. If you're looking at number 1 on your notebook paper, I'm going to put that one in. So I'm going to bring up alpha y equal for a fraction. And I got my -5 over 3x minus 6. That's going to go into y1. And then the second equation, 1/6 x plus 5 is going to go into the y2. And then we'll graph. So you can see very quickly, looking at the graph on the graphing calculator, that the blue line and the red line do hit each other. They hit each other one time. And they hit, it looks like -6, 4. If you want to double check, if you go to your table of ordered pairs and look at the -6, what you should notice is that the y coordinates on the blue line and the red line should match. And that's what you're looking for. The solutions should match on both equations. Just real quick, before I move on, question number 4 is no solution, meaning that if you look at these two equations and you graph them both, they should not hit each other. These should be parallel lines. The solution is going to then be no solution. And number 6, when you look at these two equations, they're going to be the same exact equation. So number 6 is an example of infinite solutions. Very quickly, if you look at number 6, the first equation, divide everything by a -1, and you get y equals a positive x plus 6. For the second equation, the y is on the right side. I'm just going to quickly divide everything by 3. And it's going to say y equals 1x plus 6. And what you notice is that your equations are exactly the same. So there's not any point in me graphing these two equations on a coordinate plane. If I can look at them and go, those are the same equation, they're going to have all points in common. That's infinite solutions. For number 4, the second equation looks great. Y equals -1/2 x minus 5. Looking at your first equation, we want to subtract the 3x first. So it says 6y equals -3x minus 12. And when we divide everything by 6, we get y equals -3 divided by 6 is going to reduce to -1/2 x. And then -12 divided by 6 is -2. Now, what you should notice here is that in both equations, the slopes are the same, but their y-intercepts are different. So in this first one, the slope is -1/2 and the y-intercept is -2. And the second one, the slope is -1/2, but the y-intercept is -5. So basically, your two equations are starting at two different points, but they have the same slope. So these two lines should be parallel, giving us the no solution. I'll show you really fast. Y-intercept of -5, and then a slope of -1/2. Rise -1, run 2, so down 1, right 2. And there's that first one. The second one has a y-intercept at -2. Again, same thing. I'm going to go down 1, right 2. And you can see that they indeed are parallel, giving us no solution. So let me jump over to the second part of the notes where we are going to solve by substitution. The steps for solving by substitution are written out for you here. Number 1 says to solve one equation for x or y, meaning you need to isolate that variable. Secondly, you're going to substitute the resulting equation from step 1 into the other equation for that variable. Thirdly, you're going to solve for the remaining variable. And then fourthly, you're going to substitute your answer from step 3 into either of the original equations to find the other variable. So I'm going to start with example number 8. Number 8 says y equals -5x plus 30 and 7x plus 3y is equal to 42. The first equation is already set up for us. If you look at step number 1, it says to solve one equation for either x or y. The first equation already says y equals, so I'm going to use that to my advantage. And I'm going to substitute -5x plus 30 in for y in the other equation. So instead of saying 7x plus 3y, it's now going to say 7x plus 3 times -5x plus 30 equals the 42. And what you'll do is you'll go ahead and solve this. So step number 3 says to solve the remaining. Distribute. So we got 7x plus, actually that's going to be minus, because 3 times -5x is -15. So minus 15x plus 90 equals 42. I'm going to combine my like terms. 7x minus 15x is a -8x. Then we're going to subtract that 90. 42 minus 90 is -48. And then divide both sides by the -8, and you get x equals 6. So that is just half of your answer. If you think about solving by graphing, these two lines should intersect at an ordered pair. Half of your answer. That's all you got right now is 6. I need to find the y. To find the y, you're going to substitute one more time. Take your 6 that you got for x and substitute it in. I'm going to use that y equals -5x plus 30 and substitute in that 6. -5 times 6 is -30, plus 30 is 0. So the y coordinate is 0. All right, so I'm going to do one more. I'm going to choose number 11. We're going to look at number 11. Number 11 says 2y is equal to 6x plus 10. And 3x minus y is equal to 5. I am going to use that second equation, and I'm going to make it say y equal. So the first thing I'm going to do is I'm going to subtract the 3x on the other side, and it says -y is equal to -3x plus 5. And then I'm going to divide everything by the -1. And we get y equals 3x minus 5. Now I'm going to take that 3x minus 5 and I'm going to plug it in for the y in the other equation. You can't use the same one you just used to solve for the y. You got to use this different one. So now instead of a 2y, it's going to say 2 times 3x minus 5 equals 6x plus 10. So I'll distribute, and I get 6x minus 10 is equal to 6x plus 10. Now, what happens here, and I'm going to write this out, even though you guys probably don't need this, but when you go to subtract 6x, what ends up happening is your x's are going to go away on both sides. And what you have left says negative 10 is equal to positive 10, which is false. Negative 10 never equals positive 10. So that's going to give us no solution. And that's what that would look like. If that happened to be 10 equals 10, then that would be infinite solutions. Just for a quick little tidbit of information on number 12, I would not use substitution on a question like number 12 because every single one of my variables has a coefficient. And if I were going to use solving by substitution there, it would create a lot of fractions. And there are other methods that we could use that would be easier than substitution, creating all those lovely little fractions. So there are your notes for Unit 1, Chapter 3, Lesson number 1.